All right. 7.4. We are going to be graphing rational expressions, and there are lots and lots of rules. Okay? So, let's say I have this. Okay? Each one of these factors has a specific structure on a graph. Okay? So, rational expressions typically look like this. Some kind of curves that have vertical asymptotes and horizontal asymptotes, and then a whole bunch of squiggles in between. Okay? So here are the structures. Anytime you have a factor that cancels, that creates what we call a hole. So the graph could be flying along, and at, well, let's say it looks like this. If that's my graph, I would have a hole right there. Just a missing spot on the graph. It's just blank. And if you graph this in a calculator or on a computer, you're not going to see that hole, because the calculator just graphs a whole bunch of dots and then connects the dots. And so it's going to graph a whole bunch of dots and connect the dots, and you won't even see the hole. You just sort of have to know it's there. And you can know that it's a hole because this graph is identical to that graph with one exception. The hole has been plugged. Does that make sense? So if I graph this in my calculator and I graph this in my calculator, they're going to look exactly the same. The only difference is when I canceled those, I plugged the hole. Okay? All right? Any factor in the numerator that does not cancel is a root. So this graph is going to hit the x-axis at 1. Okay? And any factor in the denominator that does not cancel is a vertical asymptote. Okay? And then the other thing we have to worry about is the HA, the horizontal asymptote. And we learned last time that if the top is strong, or sorry, if the top is weaker than the bottom, then my HA is y equals, so y equals 0. If the top is equal to the bottom, and what do I do? What do I mean by equal? What are we comparing? The degree. So the largest exponent. If the top has a smaller largest exponent than the denominator, then the HA is at 0 every single time. Okay? If they're the same power, then y is equal to the ratio of the leading coefficients. So if I had 4x to the third over 6x to the fourth, that HA is going to be at 0. The bottom is stronger than the top. And none of this other stuff matters. But if this was a 4, now where is my HA? It's just the ratio of the leading coefficients, 4 over 6, which would be 2/3. So I have a horizontal line at 2/3. Okay? All right, so this equation here is x squared minus 5x plus 4 over x squared minus and plus, so minus 2x minus 8. Okay? And the other thing we have to look at is the y-intercept. Where does this graph hit the the y-axis? The y-intercept is always the constant of the top divided by the constant of the bottom. So this is my y-intercept. Why is that? Well, the y-axis is every instance where x is 0. So if I plug in x equals 0, this goes away, this goes away, this goes away, and that goes away, and I'm left with negative 1/2. So here's how we graph this. Okay, I have a root at x equals 1. So we cross the x-axis at 1. I have a y-intercept of y equals negative 1/2. So I'm going to put my y-intercept at negative 1/2. Okay. I have a VA at negative 2. So negative 2 is a VA. And I have a hole at 4. And what about my horizontal asymptote? It's 1/1. So I have an HA at 1. Okay. Now most of the time, you can look at this graph and draw it from that information. So the graph is going to look like this. The only place I can cross the x-axis is right there. The only place I can cross the y-axis is right there. I'm not allowed to hit my VA. And when you have a VA, if one side is down, then the other side is up. So the graph is going to look like that. Okay? I'm missing one thing. The hole. So over here at 4 is a gap. And that is my rational expression. Okay? So this is the hole. X minus 4 is where the hole is, so it's going to be 4. Okay, so we're going to do a whole bunch of these. So I'm going to pull out a 2, and I get x squared plus 3x minus 4. Factor everything. 2 times x plus 4 and x minus 1 over x plus 2 and x plus 1. Did I do that right? Nothing canceled. Take out a 2. Two, 2, 4. Yeah, okay. So what does this look like? Well, what happens at negative 4? If it's on top and it doesn't cancel, what would that be? A root. And here's why. Watch what happens when I plug in 4. When I stick 4 in there, I get 0. Right? Well, what is 0 times this? 0, whatever it is. Right? And then what is 0 divided by all of this stuff? 0. So if the top is 0, then the whole equation is 0. So that's a root. So I have a root at negative 4. Sorry, I did that wrong. I meant negative 4. Okay. What does this do? It's a root at 1. It doesn't cancel. So there is a root at 1. Okay. What is this? A whole would cancel. So if it doesn't cancel, it's a VA. So negative 2 is a VA. Okay. What about this one? That's another VA at negative 1. Okay. And then what does this tell me? The horizontal asymptote is at 2. The bottom and the top are the same strength, so I divide the leading coefficients. So I have an HA at 2. Okay. And what does this tell me? not whole. When x is 0, it's the y-intercept. So the y-intercept is at -4. Okay? So you don't actually have to graph it on this one, but I think it's good that you just see all of it at the same time. So it's pretty obvious that the graph has to do this, right? Okay? So if this side is down, it means that the other side has to be up. So this is going to come down. Now, as that comes down, it can do one of two things. It can either come down and through and down, or it can come down and curl and go the other direction. Which is it going to be? Has to curl. And there are two reasons why. Why is that? The other side has to go down. How else do I know that it curls around instead of goes through? There's another way to tell. Do I have a root there? No. So I'm not allowed to punch through the x-axis unless there's a root. So this graph has to look like this. It has to go down and turn around and come back up. And then this one would look like that. Okay? All right, let's do another one. All right, so 5 over, I'm going to pull out a negative because nobody taught you how to factor with a negative out front. Okay, so 5 over x plus 2 and x minus 1. Oh, plus 1. Okay. What does that tell me? Vertical asymptote at -2. What does this tell me? Another one at -1. Okay. What does this tell me? The HA is at 0 because the bottom is stronger than the top. Okay. And what does this tell me? Y-intercept is at -2.5. And that's all I need to graph it. So this has to look like that. What's going to happen in the middle? I'm going to come down from the top. Am I going to go through or turn around? I have to turn around because there's no root. I'm not allowed to hit the x-axis. And so the left side has to be on the bottom, like that. Now, sometimes you can't tell. Let's say I had this graph here. Why can't it be here, you mean? So these have to be in opposite directions. Yeah, the vertical asymptotes, one side is up and one side is down. Now, there is an exception to that. So if it was x plus 2 squared, that means you sort of have two vertical asymptotes. And if you have two vertical asymptotes in the same place, that means that the two sides go together instead of apart. And I don't know that that's going to happen, but it can. Does that make sense? It's like, remember when we had two roots in a quadratic? It bounces off the x-axis. So if you have two vertical asymptotes in the same place, if one side is up, the other side is up. Or if one side is down, the other side is down. Okay, so let's say we had this. And I had a root here, and I had a root here. Well, it's obvious that this one looks like that. And then what's going to happen in the middle? Has to go through like that. Okay. And then this would be the other side. Does that make sense? But what if there was another root over here? And actually, there would have to be two of them. There could be one, but two will make more sense. So, can I start from down here? No. So I have to start from up here. Am I allowed to go through the HA? Yeah, you can go through the HA, just not on the edges. The HA really only applies on the far right or the far left. So this is going to come down and hit that. And then what? It has to loop around and hit the other one. And now it has to obey the HA. Okay. What if we had this? This equation has no roots, and it does not have a y-intercept because there are asymptotes in the way. So how do we know where to graph it? Well, we would have to look at that equation, so it would be something like 3 over x times x minus 4. Okay. How do we know how to graph this one? Normally, we put points on this line, and we put a point on that line, and that teaches us where everything goes. But in this case, both of those are forbidden, so we have to just plug in a number and get an answer and use that. What would be a good number to plug in? What x value would be a good number to plug in? Well, 0 is usually pretty friendly, but in this case, 0 won't work because it's an asymptote. So we could try 5, sure. So 3 over 5 times 5 minus 1, or 5 minus 4, which is 3 over 5. So over here, 1, 2, 3, 4, 5. And all I really care about in this case is it above the HA or below the HA? 3/5 is above the HA. And now I have everything I need. This is going to look like that. There's no other way to do it. I can't go through the x-axis. And if this side is up, then this side must be down. So I'm going to go up there. What's going to happen when I approach the x-axis? I have to turn around because I have no roots to hit. And so on the other side, it would look like that. Okay. What if I change this to an x squared? Which means this is a double asymptote. How is that going to affect the graph? So this has to look like that. Because it's a double asymptote, these two sides go in the same direction. Does that make sense? Okay. So that's what you need to know. And here, well, let's do another one. All we have to do are the asymptotes. So negative x squared plus 4x plus 4. So this is x plus 2 and x plus 2. Oh, look at that. And then x minus 1 and x plus 1. So what are the asymptotes? We have one at -1 and we have one at 1. What about HAs? Where is the HA? -1. Right? So the HA is at -1. And now let's just go through and graph this because it's good practice. What it, oh, geez. I'm hearing what you're saying. How about we put it where it belongs? Right there. Thank you. Okay. What is this? It's a root, but it's actually a double root. Do you guys see that? So at -2, I have a root, but it's going to bounce. That's going to be a little weird. Okay. And then what does this tell me? The y-intercept is 4. Okay. All right. So, ooh, this is tricky. Where are we going to graph this? So I have to have a bounce. Either it's going to bounce like that, or it's going to bounce like that. Which one is it going to be? It has to be the bottom one. Why? That's the only way to approach the HA, right? If I bounce here, there's no way to get back over there. There's no more root. So we just learned that it's going to look like this and a bounce. And then am I going to go down or am I going to go up? I have to go down. Why? There's no root. There's no way to go through. So this has to be down. Am I allowed to go through the HA? Yes. The HA only applies on the edges. Okay, now what? The middle has to be a U. Has to look like that, which means this one is going to look like that. Okay? So if this is up, then that has to be down. Unless it's a double asymptote. So this is a single asymptote, which means one side is up and one side is down. Good question. All right. So they don't even give us the equation. We're just using the graph. Where are the x-intercepts? This one has none. The y-intercept is 1. The vertical asymptote is x equals 4. The horizontal asymptote is y equals 0. And the domain. So the domain is every possible x value. Which x's are on the graph? So does this x, -2, have a spot on the graph? Yeah, it's right there. Does this one have a spot? Yes. So if I go through and mark all of those, which ones hit the graph? Everything except 4, or 3, 4. So how do they want us to do this? Okay. So we basically want to describe everything over here and everything over here, just missing 4. Have we done interval notation before? Parentheses and brackets? Yeah? Okay, I thought so. So x equals, you can either use parentheses or brackets, and you always do low comma high. Parentheses means not equal, and brackets mean equal. So what is the left side of this chunk? -infinity. So x equals -infinity. Does infinity get a parenthesis or a bracket? Can we get to -infinity? No, so it's not equal, so it gets a parenthesis, okay? The right side of this is 4. Does 4 count? No. 4 is where the asymptote is, so we cannot equal 4. Okay, and then we union with that with, what is the right side of this piece? Or sorry, the left side of that piece? 4. Does 4 count? No. And then what's the right side of the right piece? Infinity, and it always gets a parenthesis. So that is the domain. Yes, every time. Yeah. Okay, now let's look at the range. If I were to draw all of the y values, which ones hit the graph? 0 and larger, or above 0, right? So the range is y equals, the smallest possible is 0. Do we ever actually hit 0? No. And what is the largest possible y? Infinity. Okay, let's do another one of those. All right, so the domain is going to be negative infinity to negative 2 union with negative 2 to infinity. And the range is going to be 0 to infinity again, because it's from 0 up. Everybody good there? All right. Yeah. So I'm going to pull out a negative 2x minus 7, or plus 7. Pull out a negative 2x plus 1. Okay. So it wants vertical, horizontal. We're just going to do the whole thing, just for review. Okay. So I have a VA at negative 1/2. Okay. I have an HA at 1. I have a root at negative 3.5. And I have a y-intercept at 7. So it's going to look like that. Now you don't have to do all of that. All it wants are the asymptotes. Okay. All right. So 2x minus 1 over x, negative x minus 2. So I have a VA at 2. I have a root at 1/2. Negative 1/2 is my y-intercept. My HA is at negative 2. So the graph would look like that. Okay? So none of these parts is difficult, but there are just so many pieces that you have to put together in order to graph these. Okay. I want to hold off on this one. Okay. All right. So negative 3x and x minus 5 and x squared minus 5 or minus 5, sorry, x minus 5 and x minus 2. Okay. I have an HA at 2, or a VA at 2. I have an HA at negative 3. Okay. I have a root at 0. And what about 5? 5 is a hole. So wherever the graph is right here, I need to make sure I draw a hole. Okay. And then what about my y-intercept? it's 0 over 10, which is 0. And you'll notice I have already graphed my y-intercept. If x equals 0, then the y-intercept is 0. Okay? So the graph will look like this, like that. Okay? And so you're going to, it's, okay. So it wants you to plot 2 points on each side of the graph. Well, I know that that is a point. Okay? And if that's a point, these graphs are symmetric. So if this is up 3 over 2, if I go down 3 over 2, that's going to be a point as well. So now I need to plug in -1. Oh, that's such a mess. Whatever, we have to do it. So -3 times -1 squared plus 15 times -1, and then -1 squared minus 7 times -1 plus 10. So this stays -3, and this becomes -15. So -18 over, that is a 1, that is a plus 7, and that is a plus 10. So that's -1. So when x is -1, y is -1. So -1, 1. There's my other point. And then up 2 over 3, down 2 over 3. Okay, that's fine. So here's how we graph it. All right, so I'm going to put this at 2 and this at -3. No, is that right? Sorry. I got that wrong. All right, this at -3. Okay, and then I need to put a point Oh, 0, 0. Come on. I can't see. Okay, so we'll put a point right here and a point right here. I need to put this right. Was it 2 or 3? Oh my goodness, I'm sorry. No, it should be, yeah, it's 3. It's -3. Right there. Okay. So then this is up 3 over 2, so down 3 over 2, and up 2 over 3, so down 2 over 3, and that will help me draw the graph, and then I need to put my hole right there. And what did I do wrong? Oh, the hole was at 5. I'm sorry. I just put my hole in the wrong place. Okay. I don't want to do these yet. So the 2 that say quadratic over linear, don't do those yet. Okay? Get to work.